Hey, welcome back to the Routing Loop. We've got a great session here today. I'm Matt Lewis, one of the hosts of the Routing Loop. And we've also got Jordan and Christian, both solution architects at AWS. You guys have been around for a long time, right? You're both 5 years plus at AWS working on all things networking. How about we just do a real quick intro? Jordan, tell us a bit about yourself. What do you normally work on?
Sure. Hi, guys. My name is Jordan. I'm a networking specialist, solutions architect, been in AWS for over 7 years now, 7.5, based in San Francisco, and I focus on networking services, like connectivity, traditional like transit gateway, cloud one, VPNs, direct connects, but also like DNS and others, any networking product. So yeah, happy to be here, guys, and do this session today. Christian?
Sure. Yeah.
I was just going to say, I think like any of the network specialists in AWS, we used to crawl around data centers and run fibers and cables and all that kind of stuff too. I'm sure you've done that in a past life as well.
I actually used to do that. Yes, literally running cables, and that was fun.
Fun times.
Yeah.
Christian?
Yeah, sure. My name is Christian Nelson. I'm also a specialist solution architect for networking. I've been with Amazon for 10 years, just like had my 10-year anniversary. Also, in my past life, I did crawl around in data centers, run cables, stack and rack routers, and all of this. Now I'm here doing more on the software side, more like on the logical side. Also covering pretty much anything under the sun, but focusing largely on anything that can really break things, which is usually BGP. So things like DS, IPAM, and then, of course, DNS is also one of my pet peeves.
Very cool. All right. I do miss crawling around data centers, but I also don't miss crawling around data centers.
Yes.
It's always fun. I mean, it's always cool to build things and whatnot, but very cool. All right. So today's session, we're going to be doing a deep dive into private DNS with Route 53. And we'll start from basics and then move to scale. And I mean, obviously at AWS, we're always talking about scale. So personally, I'm really interested in this session because I feel like I'm a little rusty on DNS. I need a bit of a refresher, so I'll be listening intently. But okay. Christian, do you want to give us a bit of a kind of a lead into DNS, and then maybe Jordan, do you want to take us away with some of the content here?
Yeah. Sure. So let me roughly frame kind of like what we're going to be covering, because DNS is a very big topic, and we want to kind of like limit it to two sub areas. So one thing is like you see private DNS. So we're not really talking about the authoritative side where you host your example.com domain on the public side, but we want to look at the private connectivity. So let's say you have on-premises connected to AWS, you have like an internal VPC, all these kind of good things, because often they get overlooked, but they are just as important and just as interesting. The second thing is we have a lot of things to cover in this area. So we had to focus on something. And what we decided to do is effectively look at all the things that were released over the last roughly 18 months to 2 years. And we're going to cover this. But we're not just going to like do like, hey, we released this and let's move on. What we're trying to kind of like frame them is like, where do they fit in? What are some of the features that have been around even longer and where they fit into the picture? So just kind of like that you don't get disappointed if you don't see all the good things that Route 53 have to offer. We basically picked like 3 themes or 3 topics in it. But if you have questions, feel free to ask anything about Route 53, anything about DNS, so we can cover that.
I think as a solution architect or even a practitioner using AWS, it's just so hard to keep up to date with everything that's changed. And I find myself getting caught out sometimes. I'm talking to a customer and say, oh, well, here's a workaround and what we can do for a particular thing. And then someone else says, didn't you guys just release a feature last week that fixes that? So super interested in the new features. Very cool.
Yeah, a lot of features. And also last reInvent, a lot of networking features came up, right? So hard to keep up.
Every year.
Yeah. Anyway, we'll do our best to
all right, Jordan.
DNS here. So, all right, let's put like a little bit of the agenda for today, right? As Christian was saying. So, I'm gonna be going and covering some of the DNS foundations. I know this is gonna be like basic stuff, but it's good to set up that level, right? And then we can start talking about like how is DNS, being implemented on traditional on-prem data centers, and then how is that being implemented on AWS. And then we're going to be jumping into private hosted zones, like forwarding versus delegation. There is a new-ish type of endpoint that allows us to delegate domains, the authority to AWS and vice versa. So we're going to be covering that. And then we're going to also be covering how you can use AWS IAM condition keys to allow certain users to do certain changes only when it comes to changing records on DNS. And finally, we're going to go on to the Route 53 profiles. It's a pretty cool feature on Route 53. So yeah, basically after that, we can keep this conversation, with questions, or else we'll have time at the end as well. So, but yeah, I'm hoping we can keep this interactive. So you guys, please do interrupt me as many times as you can.
And just like any other routing loop session, any questions in the chat, please post them in there, and we'll interrupt Jordan and Christian to get your questions answered. So don't be shy.
Absolutely. All right, so let's start with the DNS foundations. So DNS, what is DNS? So DNS at the basic level is a user wants to resolve domain name. And the way it's done is that user will make a query to a local DNS resolver, and then that local DNS resolver will be responsible for initiating all these queries first to the root server. If it doesn't know it, of course, if it's cached already on the local resolver, it's just going to give a response back to the user. But if it doesn't know the answer, it's when we will start all these different queries to different servers. The first one being the root server, also known as the dot. And then that one will make a referral. Let's say we want to resolve example.com. So if we don't know anything, we'll go to the root server. The root server will say, okay, here's a referral to the top-level domain.com. So you have to ask that authoritative name server for that .com, right? So then the local resolver, the local DNS resolver, will make a query to that top-level domain, and that top-level domain server then will respond with also a referral saying, hey, you're trying to reach example.com. Here's the authoritative name server for that, so please go ahead and ask that guy, right? And at the end, hopefully we'll get an answer back to the local DNS resolver, and the DNS resolver will be able to give that answer back to the user. Okay, so that's a very basic way to describe how DNS work on traditional setups, right? Now, if we look on how this is being done on AWS, it's similar. It's just there are a few things that is good to know how it works. So let's set up let's talk about a basic example, like a VPC with like an EC2 instance. Again, same thing, trying to resolve example.com. So the first thing that EC2 will do is will try to reach the local resolver, which in this case is the .2, right? The .2 IP of that VPC. And then the local resolver will go through a series of checks in order of what do I check first. The first thing it's going to check is if there are any forwarding rules. And we'll talk about it, by the way, like the forwarding, when we talk about the forwarding versus delegation and whatnot. But the first thing that resolver is going to do is to check if there are any forwarding rules. Do I need to forward this to somewhere else? If there are no forwarding rules or no matching forwarding rules, then the second thing is going to be, okay, I'm going to look up at the private hosted zone that is associated with that VPC, okay? If we have a record, good, it's going to give an answer back. And if not, it's going to go and check if that belongs to any VPC DNS. VPC DNS means when you create a service, like, for example, the EC2, there's going to be a DNS name associated to it. So it's going to check if that name that we're trying to resolve belongs to any of those, like FQDNs, right? Then if none of this, we haven't got an answer from any of those, then it's going to assume, okay, this is not within AWS. We're going to start then similar to how we do it on traditional DNS setups. I'm going to go to the root server, right? Outside, I'm going to check, it's going to get a referral. Then I'm going to go to the top level domain. And then finally, we'll get that referral to reach the authoritative name server for that FQDN, right? In this case,
I have a question.
Example.com.
So right now we've got a resolver that's sitting inside AWS Cloud, that box around the purple box, which is a VPC. How are we getting out of AWS Cloud or out of the VPC? Like what mechanisms would you use there?
Yeah, sure. Christian, do you want to tackle that question? Or?
So you mean in this case, like how the whole thing behind the scenes work? Or let's say we want to connect to on-premises?
Well, I'm just, so on-premises is on the left-hand side. Is that right?
So on-premises would be, we'll probably add it later in one of the slides when it builds up, would be then on the left-hand side. In this case, you can create, and we have it, like, I don't want to like do too much of what John is going to show you. We have these like resolver endpoints where basically the traffic would then leave through one of these endpoints and hit on premises. But I think in this case, like the lines that you see, the white lines, they're like behind the scenes. They're not going out of your own VPC. So I think that's an important thing to keep in mind, is that you can have a resolution even if you don't have a path out to the internet. How useful that is a different story. Like, of course, with like public resolution, it doesn't really make sense if you can resolve example.com or Amazon.com, but your EC2 instance cannot go out. But the white lines are not traffic inside of your VPC. Like once it hits the resolver endpoint, it's basically behind the scenes. And that is an important thing to later keep in mind. We're going to come back to this one, where like you can do DNS resolution where the traffic basically goes behind the scenes and resolves stuff.
Yep, we're gonna definitely be talking about this later on. Also, like something to keep in mind is that authoritative name server that I'm showing outside of AWS, it could also be inside of AWS, like hosted on a public hosted zone, right? Although today we're focusing on the private, but just for the record, right? This could also be like within AWS itself if we are hosting that public, domain on AWS Route 53.
I see. Okay, so I think the answer to my question was I don't need to build connectivity for the white lines that we're seeing going out of AWS. That's something that is being taken care of for me. Okay, very cool. Let's keep rolling. And if I'm going to steal your thunder by asking a question, just tell me that's coming right up. That's
all good. Yeah. You're spoiling it, Matt. That's all good.
I'm good at that.
All right. Okay, so that was DNS at basic level. So now let's talk about the Route 53 private hosted zones forwarding versus delegation. Like what does it mean, and what do we do on AWS, right? So what are the difference, first of all, between like forwarding and delegation, right? Let's talk about forwarding. If we look back to the previous diagram and we focus on the AWS side only, the first thing I say before, where the VPC resolver, that local VPC resolver, is going to look for is if there are any forwarding rules. What I mean by that is we might have, an on-prem data center running with some servers, like a typical common like hybrid connectivity, and then there might be some DNS names that we need to resolve that are on the on-prem. And also the on-prem might have to resolve some of those records which are hosted on AWS, right, on Route 53. So how do we achieve that, right? Back to your question, Matt, I guess the first thing we need is obviously like to have that connectivity. In this case, we're talking about like data centers, right, like on-prem connectivity from that on-premises side to AWS. So we're going to have like direct connect or site-to-site VPN, something, right? So those two can talk to each other. And then in this case, we're going to be looking at outbound first. We're going to need to have like an outbound resolver. So that outbound resolver can then send that query to the on-prem DNS server, which, it's having that particular record that we want to resolve that. Vice versa, like so what we're gonna do, that outbound resolver is gonna send the query to the DNS server and expecting an answer back to that outbound resolver, and it's gonna follow the same path, right, to get back to the EC2 who initially requested that. An important point here is this is a recursive query, as in this resolver doesn't support like the iterative, like the referrals and all of that. It's like, okay, I have a forwarding rule. I'm trying to resolve this name. I don't know. So I'm just going to forward it to that guy, the on-prem DNS server. I'm expecting an answer, and that's it, right? That's basically what this resolver is used for, just to forward that to external side, right? Finally, that is going to get back to the EC2. If we look at the inbound use case, very similar. So we're having like a client on the on-premise who wants to resolve a record on AWS, on Route 53, on a private hosted zone. For this use case, we're going to use an inbound resolver. So when a client sends a query to its local DNS server. That local DNS server is going to have a forwarding rule similar to how we had it on AWS to forward that query to that inbound resolver. And then that inbound resolver through the local VPC resolver is going to send that query to the private hosted zone, hopefully get an answer, and via the same path is going to then send the answer back to the local DNS server and the client. Okay. All right. So we talk about forwarding. Let's talk about delegation. What is delegation and how it works? Let's say we have a example.com, a parent domain, which is hosted on premises, as an example. And then we might have like multiple entities. One of them being healthtech.example.com. And that might be hosted like in another facility somewhere else, also on-prem, as an example. So we might want to delegate the authority of that subdomain, the healthtech.example.com, to that particular location, to the name servers running on those locations. So they can be the authoritative for that particular subdomain, right? The healthtech.example.com. And then we can keep doing that. We could like keep subdelegating this. In this example, I'm showing like aws.healthtech.example.com. So you could be subdelegating the authority to other name servers in another facility, or we'll be talking about like on AWS. So those name servers become the authoritative name servers for that particular subdomain, the aws.example, healthtech.example.com. Okay. And we can keep like doing this, right? So the parent domain remains example.com, but then we have entity 2 as a fintech in this case, entity 3 like a retail, etc., etc. Now the difference here is when a user makes a request, he wants to access, he wants to resolve, for example, app1.los.example.com. In this case, the way the queries work, it's slightly different. So it will again go to its local DNS resolver. And then this one now, it will start these iterative queries to the different authoritative name servers. So the first one being the example.com. Then the example.com is going to say, hey, I'm not the authoritative name server for actual that subdomain. So you have to, I'm going to send you a referral. So you go ahead and query that one. And then the health.example.com is going to say, hey, that's being delegated to to aws.example.com. So I'm going to send you referrals so you can query directly the name servers who are authoritative name servers for that particular subdomain. Okay. Finally, we'll get a response back to the local DNS server, DNS resolver, and that will be forwarded to the user so that they can get an answer for that. Okay. The difference here, as you can see with the arrows, in this case, we have iterative queries instead of like recursive queries, if that makes sense. Now, the way it works on AWS, it's a similar concept that we just discussed before with the endpoints, but it's a new type of endpoint. We're still going to have that private connectivity using direct connect or site-to-site VPN to connect our on-prem data centers or offices, a hybrid scenario. And then in this case, we want to have an inbound endpoint on AWS to be able to get requests from the on-prem and be able to resolve like records which are being subdelegated to AWS. So in this case, we have like if you look at the right side of the screen, we have the private hosted zone with the subdomain aws.healthtech.example.com. That's being subdelegated to AWS. So when a user on the on-prem does now a request to that particular subdomain, it's going to be a similar path, but in this case, the authoritative name servers are on AWS. So we can forward that, or we can get that referral to point to that particular endpoint, inbound endpoint, which is now being used for those delegations, those different subdomains. Okay. Similar path, that endpoint now supports these iterative queries, so we'll be able to check by a raw53 that private hosted zone, and then get a response back to the user. But again, following the same path, it's not just like a recursive query, which is like I'm making a query and need an answer. Now I'm able to make those referrals, so this endpoint can also process this type of requests, the iterative queries.
You've got Direct Connect or site-to-site VPN. Does it matter where my on-premises is? So if there's 100 milliseconds of latency, would you want to not do this, or what are some of the limitations around setting this up?
As long as you have private connectivity, you can reach that endpoint, those IP addresses. Not sure. Christian, do you see any limitations in here?
Yeah, so I think it's the next slide or the one after, where we're going to talk about, instead of delegation, we're going to use forwarding. So there's one use case that we're going to cover all the way at the end, where you can effectively say, all the traffic from on-premises, I'm going to forward you to AWS, where I can do all the smart things like DNS firewall, and then I send it out to the internet. There, one of the things to keep in mind is basically like the location that the internet sees where this traffic is coming from is the AWS region. So in other words, like let's say you have a AWS region in Sydney, Australia, but your user is actually sitting somewhere on the beach in Fiji or in the mountains in New Zealand, they all appear to be coming from Sydney.
Got it. Yep.
Right. I love the non-US examples you're using there.
Of course.
Okay, let's keep rolling.
All right. Very similar, so I'll be quick here. For the outbound, in this case, we have like the example.com name on AWS, and we want to subdelegate the subdomains like healthtech.example.com onto like from AWS to on-premise. So very similar. We're going to be using like an outbound resolver for this. So when I need to make that request, we're going to have those forwarding rules to then send those, saying basically, hey, I'm not the authoritative name server for this. You have to send it to the on-prem name server, who is actually the authoritative name server. Okay? So following the same path, it's just now the reverse from AWS to on-prem. Here's a great blog if you guys want to have it's a good read on how you can manage, streamline like hybrid DNS management using these new type of endpoints, the delegation endpoints. So please scan the QR code. It's a nice read. We've been looking into like a few blogs and everything, and we believe this one it's a great one if you guys want to have if you're interested in this type of endpoints. Okay. All right. Now let's jump into the second topic: AWS IAM condition keys. How we can use them. So we can implement fine-grained Amazon Row 3 access using AWS IAM condition keys. What does it mean? We might have in a scenario. We're going to be talking about a single account first. One account, and then we have a domain example.com as an example. And we have like 3 subdomains, like SVC1, SVC2, SVC2, 3, example.com. And a great example could be, for example, like a shared VPC, where we have like multiple users, and they might want to make changes to those records, to the SVC1, 2, and 3. So how do we make sure that the right user make only the changes to the right type of record, and not everyone is able to do like change anything in there, right? So we can use the AM condition keys, which basically we can authenticate the users in a way that they will be using a key, that key, and a value that is then going to be presented on AM, and AM will then determine if that user can do changes to that particular record. So having those keys and those values, that key, that value, when they make a request to do a change, that's going to be analyzed against the permissions they have. And it's going to say, hey, yes, that particular user can modify like anything on that domain, or that particular user cannot change anything except this, or they can change everything except this, etc. So it's very flexible. There are like 4, I think, if I remember correctly, Christian,
Yep.
4 different types, right, of things they can change, like as in everything except that, nothing except this. They have to match exactly this. So yeah, that's the way you can control as per user what they can do.
Yep. So there's one matches exactly, another one matches the opposite, and then like, and then not like. So that's like, we show some examples, I think, later, how you can use it to match certain conditions.
Perfect. And very similar when you have more than one account, like between accounts, you can do exactly the same thing. The only difference is those users from account A will be assuming a role into account B. And then again, some sort of like conditions keys they need to match for that user to be able to do any change to that particular name, okay? So multi-account also works. So here's another blog for you guys if you're interested on implementing anything like this, where you can control like the users, what changes they can do. Here's a good read, very useful. All right, now let's talk about profiles and what is Route 53 profiles. In a nutshell, you can think of profiles as in a container where you can put all your DNS configuration and manage it at scale. And we'll go through some of the slides now and scenarios. It will make more sense. But essentially, instead of having to manage like all these private hosted zones everywhere, you can create like a profile and then apply this profile like to as many different accounts or VPCs that you need to apply that particular profile. It's creating like a container where you have all your DNS configurations. Let's look at an example. I guess it will be more a little bit clearer. You have your AWS organizations where you will have multiple OUs and accounts. One management account, for example, where you manage all your cloud administrators and the resources access manager, the SSPs, etc. Then you may have your infrastructure account. Within there, you will have your networking account, where we recommend to have all the networking products, where you can manage all your networking stuff from that account. And for example, the on-prem, the hybrid connectivity could be into that account, to a VPC where you have your endpoints. And in that networking account is where, I mean, you can do it in any account, but the recommendation is you can manage it centrally from like a networking account. You create a profile, and then within that profile is where you put all the configurations, as in like the private hosted zone, or private hosted zones in plural, like you can have more than one. Your DNS firewall rules, your resolver rules, your VPC endpoints, and the logging as well. You put all of these configurations into a profile, and then that profile can then be shared across other OUs and accounts. And you can apply that same profile to all the VPCs that you need to apply on that particular account. Okay, so it makes it very easy from a management perspective. You create this container, this profile, and then you can share that profile with other accounts, and they can associate all their VPCs that need to follow the same sort of like DNS configuration.
This seems immensely powerful. Are there any limits on how many accounts we can share a profile with, or anything I need to think about?
You can share it with your organization. One of the things we'll talk about, I think Christian, you will touch a little bit as well, is on it is a limit, like it is regional, as in it's only like regional, and then there is a workaround to make it like across regions. But yeah, one of the limits will be you can apply this within a region. That's one of them. I don't know, Christian, if you want to add something.
And then
I would also never shy away from any comments about price. So Irene says that they're great, but a little pricey. Unfortunately, that's not something inside our realm of influence, but point taken.
Yeah, and at scale, it definitely saves you a lot of pain, maybe worth it paying for it. We'll show you some examples later. It's like, yes, at a small scale, this might be a bit overkill and therefore pricey, but once you start like really growing, it's definitely worth it. Two things from my side. So one is we'll later see it's like to one VPC, you can only assign one profile. So we don't have like profile stacking or something like this. We'll show you a workaround for this later. And then this is the slide where maybe your question you had earlier is like, how do I connect to on-premises comes in again. Because you see, we only have one single VPC endpoint drawn in here. And right next to it is the resolver endpoint. Maybe we can see it. So the key message is here from these endpoints that we showed you earlier, the Route 53 resolver endpoints. You only need this inside of this account, which is connected to on-premises. So the one that you see in the lower left corner, the one that is called networking account. And that's where basically all this connectivity between on-premises and AWS happens. And then behind the scenes, what's not shown here is like all these different VPCs that you have on the right side. they can use it and vice versa. So one of the things that we very often see is that when customers have like 10 VPCs, they think they need 10 of these resolver endpoints. You actually only need one. And ideally, of course, like with our redundancy story, that you have the actual IP addresses split across at least 2 availability zones, but there's no need to create like more than one of these instances across multiple VPCs or anything like this.
Correct. Yeah, you can save some money there. Like I've seen deployments where they have it everywhere. So I guess with this, you can definitely save some money on that side.
Yep. We had at one point like, what is a resolver endpoint? Is it like if you have it across 2 VPCs, does it count as 1 or 2? So usually we call it's still one resolver endpoint, but it has the ENIs or the IPs and the different IZs. With this nomenclature, if you have more than one per region, there's something weird with your setup, and you might want to have a look or like engage someone from AWS to have a look at it. But most likely you can consolidate them into just like one per region and still have the full functionality and the full resiliency.
Cool.
Great comment. Love that.
Yeah, we'll be happy to talk to any customer about this. It's or to review what they're doing. We always enjoy.
Yeah, and I think that's a good time to just remind folks that if you want to talk to folks like Christian and Jordan, just reach out to your account teams. We're always happy to talk to customers and have a look at your architecture and offer advice. So that's something we do every day.
Yep, absolutely.
All right, let's keep rolling, Jordan.
Yeah. All right. So another way to show like or to clarify what we can do with profiles. So let's have an example where we have 4 different type of profiles. We're seeing the customer apps dev, like the customer apps prod, data platform, legacy on-prem. Like, let's say we set up these 4 different type of profiles. Common question is, do I need, like, if I assign like a private hosted zone, for example, to one of those, and like let's say the apps dev and another private hosted zone to the data platform, that's great. But do I need to keep replicating all of these private hosted zones to all the profiles I have? The answer is no. You can have, for example, a private hosted zone where you have records that apply to 2 different type of profiles, associate that private hosted zone to 2 different profiles. So you don't have to recreate, you don't have to duplicate the private hosted zone just because you have to set them up on 2 different profiles. You can just use one and associate it to both. The same applied to any other of the settings that we saw. As an example, like the DNS firewall role group, you can see we have one that is only being applied to one of the profiles, but then we have another one which is being applied to both, like the dev and the prod apps, right? So it's very flexible, it's very granular. You don't have to replicate everything, right? And obviously, you can have one of the profiles which is completely following their own thing. So you create rules and settings, DNS settings just for that profile. All right, another way to put it, like, again, account A or account 1 in this case will create a profile. For example, being the networking account, you create all the private hosted zones that you need. Again, it could be one, it could be more than one private hosted zone that you associate to a profile. You can have more. DNS firewall rules, resolver rules, VPC endpoints, query resolver query logging, and then share it with like all the VPCs that you need to. It's just another way to show it, and then you can share that with other accounts, and those accounts then will be able to also associate all the VPCs that you need to. An important note, I guess, to make is when you share this profile, there is a set of permissions that you have, like while the sharing process, and then you can give permissions when you're sharing that to other accounts for them to either they cannot modify anything, or they might be able to modify something. Like they might be able to add resolver rules or VPC endpoints. So you set up the permissions as to how you want to share that profile with other accounts, as to either like they can't change anything or they're able to change some of the things on that profile. Okay.
Yeah, I think that kind of permission structure gels very well with our customers, right? It reminds me of VPC sharing, where you're sharing a subnet, folks can participate in that, but you've got a network admin team that's managing the routing and connectivity. It sounds something similar here, where you've got a central team managing your DNS and sharing that profile and configuration out to sub application owners that might get an account or something like that.
Correct. And you might want to have this like central management, right? Because when you change the profile now, you're impacting any of the VPCs that are being associated to that profile, and that's the whole purpose actually of a profile, right? You want to make a change. You don't want to be going through like 100, different private hosted zones because you have 100 VPCs. So you want to do that. You can make the change in one single profile, and then that obviously takes effect to all the VPCs associated to it, right? But at the same time, you need to be careful when you share it, like which sort of permissions you give, because you don't want to be, impacting like a large scale of VPCs for that, right?
Mm-hmm.
So here's one blog. It's talks about like RAW53 profiles. You might see one of the diagrams I initially show when I was explaining RAW53 profiles. It's kind of like a copy paste essentially. I had to redo it, but I took it from this blog. A great blog if you want to understand like the power of RAW53 profiles. So please scan the QR code and have a read. It's a great blog to understand how RAW53 profiles work at the scale.
I think I jumped ahead a little bit on the QR code, and the link to this blog post I posted about 6 minutes ago in the chat. So that's that one there.
Oh, okay. Wondering. See, well, there we go. That one is a good one, right? It's the best one. We did our research. Which one are the best ones to show to our customers, right?
Because you could only do one QR code per slide.
Yeah, I remember I was while Christian and I were preparing this presentation for Rainband. I tried to put multiple QR codes on the screen, but then when you look at like the Rainband setup, like when the people are, customers are putting the phone up, it's like, well, what QR code is gonna go, So yeah, it's gets tricky. So one QR code.
So what you're telling me is you have a QR code for the blog post and another QR code for the Rickroll YouTube link, and it's just luck. You're going to learn about AWS or get Rickrolled.
Yeah, right. It's the challenging thing to put multiple QR codes. So, we did.
I think that unrelated, that Rickroll YouTube video, I think that is one of the highest number of viewed videos of all time. It has, I don't even know, like 100 billion or something views on YouTube. It's insane to me. Well. Anyway, back to the topic at hand.
Yeah, all right, let's keep going. The migration. I think, Christian, you want to touch upon this?
Yes. So maybe this looks familiar. So this is actually from a blog post from a few years ago. And it was an architecture that was loved and hated at the same time. Because it was basically the only way that we had available in order to scale. So you see at the top all these different VPCs, which could be either different teams like team 1, team 2, team 3, or it could be prod, dev, test, whatever, that have their own subdomain and they have their own VPC, they develop something, and now they need to have they need to be able to look up the other team's DNS subzone. So what you had to do back then is either you share every single of these private VPCs with everyone else. You can already see that just with the 3 that are depicted there, that is not trivial. Now, what happens if you add the 4th one, you have to go back to the 3 ones before, add the 4th one, and the 4th one has to basically like point to all the 3. So you see with every one that I add, it becomes this spaghetti mesh monster that you cannot handle anymore. So that's why basically it's like customers and also internally SAs started looking at what are the alternatives. And this is the best that we could come up back then, where basically it's like you see at the bottom the green and the blue dots. So that's an inbound and an outbound resolver that you point at each other. And this, again, makes use of that you don't actually need connectivity from this VPC where the inbound resolver and the outbound resolver sit in, up to the actual VPCs at the top. So these like dotted blue lines that go up there, that's all happening behind the scenes. So there doesn't need to be any like transit gateway, VPC peering, nothing like this in between. This like magically worked. Sounds great. So why are we not recommending this anymore? Or kind of like, why was it like loved and hated at the same time? The problem is like by pointing these inbound resolver at the outbound resolver, there was like some ways behind the scenes how they were built, how you were basically not getting really great resiliency. So there were like certain failure scenarios that could happen. And of course, you don't see them until they really happen. So that's kind of like where we're behind the scenes is like, we shouldn't be using it, but we don't really have anything better to use it. So it's like we don't want to recommend it to you, but we don't have anything better. And now we're like super happy because we have Route 53 profiles. And this capability of like having all these different VPCs where you need to have resolution in between them, we can now very easily resolve, because you create a profile where you then put these private hosted zones into it and you share it out. So if the only thing that you learn from today is like, if this diagram on the left looks familiar to you because you implemented it, I highly recommend to go back, revisit it, and re-architect over to the one on the right using Route 53 profiles. Because from a resiliency perspective and the pain of managing it, it's definitely a step forward. So that's what there's like. We like experimented with the slide, but that's kind of like the key message behind it is like, from the old, which is like was great at its time, but now it's time to move on to Route 53 profiles.
I'm just looking at Hiring's comment about profiles are great, but they're a bit pricing from earlier. If someone wanted to, could they still build the old architecture, and would they save money? And is it worth the complexity though? It doesn't sound like it would be though.
It's probably not. So probably the easiest way is, in this case, you would just share the private hosted zones directly. I mean, at the top is like, if you really only have like 3, 5, maybe up to 10, it might be possible. But just keep in mind, it's like with every single one that you add, you have like this number of links that you need increases dramatically. So you very quickly reach this breaking point where the question is like, yes, you saved some money at the beginning, but now you're at this point where either you increase your pain point and save money, or you finally go over to the Route 53 profiles.
Right.
So
I think any reference architectures or blog posts or diagrams that use our old AWS icons, it's always a warning red flag to say, well, maybe there's something better. So in this case, absolutely.
Yes. On this one, is like, I'm so happy that this is finally, we can move on to something newer. I think I had to update this blog post at least 3 or 4 times with like some new stuff, like some new warnings, and hopefully, yes, we have something much better now. Cool. If you can go to the next slide. And same thing is like, we have a blog post. Here's the QR code for this one, or I think Matt is putting the links directly into the chat, which shows exactly how to do this. It's like, if you have this like legacy setup, it walks you through how you can migrate over to using Route 53 profile. So that should get you set up. And then if you can go to the next one. So now let's talk about use cases. So here's kind of like the 3 different topics, or the 3 different themes that we discussed. We talked about like the forwarding versus delegation, where we have the inbound and outbound resolver endpoints. We talked about the condition keys, and we talked about Route 53 profiles. And now we basically want to take these and go from the basics that you learned up to scaling, to like where the gotchas are. Like, if you really need to scale even higher, what are some of the things that you can do? Maybe you can go to the next slide. I think we have one more prepared. So this is going back to the Route 53 profile, so I'm not going in the order that you saw it. But one of the things that we mentioned earlier is there are 2 gotchas that you have to keep in mind. One is, this is a regional concept. So the profiles exist in one region, which begs the question is like, what am I going to do if I have multiple regions? That's one of the things that we show you. But then the other thing is also, you can only have one profile at a time assigned to a VPC. So what if I need multiple profiles? So as an example is like, what if I do something like I centralize my VPC endpoints? So they all sit in one central VPC, and therefore the DNS configuration in all my other leaf VPCs are pretty straightforward, up to the point where one of them needs its own local endpoint because they're creating too much traffic for whatever service you pick, or I need to troubleshoot. And suddenly it's like, I need to change the DNS setting in this one. How do I do this? If it's just temporary, we can go back to what Jordan mentioned. So you might give that team the permission to just temporarily override it. But what if this is like a non-temporary thing or a longer thing? And then what happens if you have like hundreds or maybe thousands of VPCs and you need to now manage this? So that's where this one comes in, where basically it's like, our recommendation is to abstracted to basically is like create these profiles not by hand, but create them through automation. And then this automation will create the profiles, and then they get assigned. So you could create the default profile that you assign to each single VPC, which is like the basics. It uses the centralized endpoints. But now suddenly it's like, oh, I want to have a local private link-based S3 endpoint. And then you create automatically a profile for this, and you assign it to accounts that need it. Now, in this one, I need an endpoint for service A. In this one, I need one for service B. But in this one, I need A and B. So you see, you already have like 3 profiles. And that's where like managing this by hand becomes very untenable. And that's where using things like CDK or CloudFormation, you automatically create them, and then you can assign them. So it's like there's like a workflow behind it. And the same concept applies if you want to go across regions. So you could create basically like a profile and then replicate it behind the scenes, however you define them, across regions. And there they're going to get built via CDK CloudFormation into the local instantiation. So that's kind of like on the Route 53 profiles, they're already like by itself very powerful. But today, the limits that you might hit really at scale is the regional concept. And plus, this whole thing is like if you need a lot of different profiles on that you assign to a VPC, because we don't have like this stacking where it says like, okay, here's my base configuration. On top of it, I'm going to put like prod versus dev, and on top of it, I put this and this. So this is kind of like how we teach you how to replicate this. I'm going to pause there. Any questions on this one before we move on to the next topic?
Very cool. No questions from me. No questions in the chat too. So we can probably keep rolling here. We've got about 13 minutes left. So.
Okay. If you can go to the go back to the.
Hold on. Let's go back to which one, Chris?
The one that shows the 3 different topics that we talked about. So the one before.
All right. This one?
Right now.
This one, sorry. Let me go back. PowerPoint and its tricks. Give me 1 second. All right.
I think Matt has to reshare it.
I'm waiting for it to pop up. Don't see it just yet.
1 sec. Let me share the screen again. And I'm going to share this screen again. All right.
There we go.
All right.
Okay.
Is this the right slide, Christian?
The next one, the one after this, which has the 3 different topics.
Yeah. There we go. This one.
Yes, exactly. Yep. Perfect. So we kind of like started on the other side. So we talked about the Route 53 profiles. Let's go to the middle and give you some examples of like where you can use it or where this becomes very useful. So there are usually 2 different scenarios where this might be very applicable. One is you might have a top-level domain. So let's say example.com, where your application lives. For us, Amazon is like, well, there's www.amazon.com. This is like what everyone knows. But it's also your most critical host name. You don't want everyone to go in there and change that host name. Yet at the same time, most likely your application is managed by multiple different teams, and they might have their own subdomain or they might have different records. And this is one way how you can partition it. You can kind of like put a key on your kingdom, on your like www host name, so that nobody except a small subset or like some automation can edit it. But then at the same time, you can say it's like, okay, I give you, your team A, the permission to go edit your NS records so that you can manage your own delegation. You go delegate it into your own account. If you want to blow away everything and start from scratch, go ahead. You have the permissions in the main zone, in the example main zone, to go do this. So not only did I give them their own basically is like Route 53 zone where they can like do things, but I give them the possibility to go back and link this in. So this is if you have multiple teams. The other dimension that it often comes up is if you have like a prod versus a dev test versus a staging environment, something like this, where you also put on different permissions on each of them through the condition keys. So it's both kind of like an alternative to using a lot of subdomains and giving each team or each function its own subdomains versus like putting it all into the main zone. But you can also combine it. You can say it's like, okay, you already got your public hosted zone, but I'm also going to give you the possibility to go change the NS record for it so that you can actually manage your own delegation. So that's kind of like the key thing where this one comes up. It's very simple, but yet very powerful, because it's a very common thing. I mean, probably like everyone that has an app needs to somehow protect that nobody goes in and like changes mail.example.com or www.example.com or anything like this, or any of the other funky records that everyone needs, like SPF, Dane, and anything like this. But yet people need to go and make changes into the main zone. Same thing, I'm going to quickly pause there. Any questions on condition keys?
I think the one that comes to mind is IAM condition keys are completely separate to whether I'm using a V4 record or a quad A record, like a V6 record, right? So there's no dependencies there. If I'm using V6, this all just should work just fine. Is that right?
Correct. Yes. And the other thing to keep in mind is like the condition key you would usually attach to a role. So it's not necessarily like that you manage individual users, but you attach it to a role, which scales much better, because now you have a person that is like, this is web developer in team A. So that's probably like you have somewhere a role. So now you attach that IAM key to that role. And if you hire or someone moves on to another team, that automatically happens behind the scenes. So I think what we need to make sure is like, this doesn't mean that you suddenly sit there and click in the IAM console all these users that now access something. It's usually like a thing that you set up, hopefully one, and then behind the scenes, these roles automatically happen.
Gotcha.
Yeah, and then the last one is like to talk about forwarding versus delegation. So John showed you kind of like what the two are from a like a high level. Let's talk about some use cases, like where would you use one versus the other. So you can think about forwarding is like literally like throwing the stuff over the fence and having someone else deal with it. It's like, go have fun with it. And one of the very common use cases is from on-premises into AWS. So having an inbound endpoint for forwarding is very common and very powerful, because now your local resolver, might it be something like Microsoft Active Directory DNS, might it be your local router, might it be whatever, you can just tell this local resolver, go send everything to AWS. That's like one configuration line is like, I'm not going to like break out anything, just like go send everything to AWS. And then AWS goes and does the resolution. And there in AWS, because we have capabilities such as DNS firewall, you can actually implement a DNS firewall, which would be very impossible or hard to implement on something like a local router or something like an AD machine. Or you can also implement things like query logging if you need to kind of like keep an eye on what's happening, like what's going on. So you're actually centralizing your DNS. So that is a very common use case where you do like the forwarding into AWS. You could do the opposite. You could basically say like, well, anything that I want to resolve in my VPC, I can send it out to some third-party host. There are many out there that offer you like nice, shiny UIs and solutions to like do additional filtering whatsoever. It is possible. I don't recommend it, because you're now creating a very high or tight coupling on this external service. So we got like questions when we were actually live in Las Vegas during the event where people were trying to do this and had actually internal teams asking for this. Again, it's possible. I showed customers how to do it after I told them many, many times, like, please don't do it. And of course, like 3 months later, that particular provider had a failure in their network. And then effectively the customer's entire AWS system went down because DNS had a failure. It wasn't our DNS, it was the other one. So that's the thing, is like it becomes especially hard to monitor these kind of things and troubleshoot it, especially if this third-party provider provides any CAS-based resolution, because you don't have any possibility to switch over from one POP to another. So in this case, let's say this region is our US West 2 region in Oregon. And the closest POP for many of the providers would be in Seattle. So if the Seattle POP of this provider had an issue and you said like, oh yeah, no problem, I'm just going to fail over to San Francisco, you can't, because it's anycast. It will hit whatever the closest is. And if they haven't retracted the routing yet, or they can't retract it because something else has happened, you're not able to fail over. So that's why it is possible to do it, but it's, in my eyes, an anti-pattern because it gets you usually in a pickle. That was kind of like where forwarding comes in. Delegation. Do you have a question? Sorry.
No, keep going. Yeah.
So where the delegation comes in is this is kind of like more like a fine grain, like a scissors, where you can kind of like now give a team its own subdomain and then delegate to that subdomain. So what you could do is like on premises, when you start your journey into AWS, and now you have this team that just like starts playing around in AWS, you can give it a zone in AWS where you delegate from your on-premises to it. So we assume that everything is at the beginning, so most of your DNS infrastructure is still on-premises, and you put something like aws.example.com or cloud.example.com into a private hosted zone, and now you delegate from your on-premises environment into this one. And then you can basically just like start building on top of there, something else on top of it, and like delegate. And then eventually you might make the move where it's exactly the opposite, where now everything is on AWS, but you still have some stragglers on premises or some workload that really, really has to live on premises. And then you can do the opposite. In this case, you delegate then from AWS back to the zone where someone needs to have some kind of service that needs to have their own zone. And then you can just like delegate to it. It makes it easier than just like blindly forwarding things. So it's a bit more surgical.
So I think we're at time. Any closing thoughts from Christian and Jordan?
I would say it's like we gave you kind of like a high-level overview of like the new things out there. Go look at them. If you have any questions, go talk to your account teams. If you need help with anything, don't be shy. And in general, it's like DNS is fun. It's like, yes, it can bring down pretty much a lot of stuff, but it's like really fun and interesting.
DNS is important and fun.
Yeah.
Yeah.
Jordan, anything you want to say?
No, happy to talk to anyone who wants to know more about it. Profiles, delegation, even new other features that also came up for Route 53, which we haven't covered here today, like global resolver and whatnot. So yeah, more than happy to you guys reach out to the account teams, and we'll be more than happy to jump into a call with you.
Yeah, I think we need to do more DNS sessions. I think there's a bunch of new stuff coming around on the DNS front in AWS and Route 53. Next week, folks, we're going to be talking about CDNs, WAF, DDoS protection. Sid's going to be on and bring in, I think, Christian, one of our other essays, but another Christian, different Christian. So you're off the hook, Christian. But yeah, you're like, what? I'm up next week. Thank you very much, everyone, for joining. Thank you, Christian. Thank you, Jordan. This is a great session. And we'll see you all next week.
And thank you, guys.